But it's only in recent years that a new type of polymer has started to be developed. This is a biodegradable polymer. These are vital in the development of a greener, more sustainable world. Biodegradable polymers are polymers that once they've reached the end of their lifespan can be discarded in the compost or in the sea, decomposing at a much faster rate than non-biodegradable polymers. Their uses span from making simple everyday items such as plastics to their use as biomedical devices. But why are biodegradable polymers actually needed? The first synthetic plastic, called Bakelite, was created in 1907, and since then companies joined the innovation and started creating their own plastics. It wasn't until after the Second World War that plastic production really took off, as plastics replaced more expensive materials such as glass, paper, and metal. Production of PET plastic used in water bottles and food packaging saw the rise of single-use plastics, which, due to their popularity, meant the waste produced by plastics soared. This waste, along with the overwhelming environmental concerns of using finite resources that produce harmful carbon dioxide emissions on production and incineration of plastics, reveals just how badly biodegradable polymers are needed. Some advantages to the current mainstream plastics, such as their versatility, strength, and flexibility, making them good for food packaging and everyday materials. As packaging, they provide health benefits such as the ability to store clean water and food safely. Mechanical and chemical recycling is used to recycle current plastics. However, these recycling methods can also pose a problem. In mechanical recycling, mixed polymers from poor sorting can form unusable material. This results in plastics ending up in landfill, where they can leach chemicals. Why are biodegradable polymers needed? They are needed to combat the ever-growing environmental concerns of plastics. But what polymers have scientists created to combat the problem of plastics? Polylactic acid, also known as PLA, is one of the most widely produced and used biodegradable polymer. It is a bioplastic formed from the lactic acid produced through the fermentation of sugar that comes from corn and sugarcane. The lactic acid is condensed to form PLA, or it is formed through the ring-opening polymerization of lactide. This renewable plastic has been successfully used as packaging and in biomedical devices. PLA can degrade back into lactic acid and only has a degradability time of between 6 and 24 months compared to conventional plastics, which take thousands of years to degrade. As a result, PLA could be an alternative to the current mainstream plastics. Another upcoming bioplastic is one formed from olive pits. A Turkish scientist discovered that olive pits had similar chemical compositions to plastics, and on that basis founded a company called BioOlive that produces a bioplastic made from the pits. Olive seeds contain an antioxidant called oleuropein, which extends the life of the bioplastic whilst also speeding up the decomposition rate of the material into fertilizer, so that it only takes a year. Using olive pits as plastics avoids the consumption of fossil fuels involved in everyday plastic production and reduces the waste produced by this plastic. So, how do biopolymers actually degrade? There are two methods that can be used to degrade polymers, depending on their structure. The main method of breakdown is hydrolysis. This is when a polymer is exposed to water, such as being disposed of in the sea, and the water molecules penetrate the polymer and randomly split the chemical bonds within it. The long polymer chains become smaller, and further breakdown of the bonds results in a reduction of the physical and mechanical properties of the polymer. The final stage of this hydrolysis is when enzymes metabolize the remaining fragments of the polymer chain. The second, less used method of breakdown of a polymer is enzymatic degradation. This is a complex process in which an enzyme causes the breakdown. The structure of the individual polymers is key to whether it will be broken down by the enzymatic or hydrolysis method. Often it is found that natural biodegradable polymers degrade more by enzymatic degradation than synthetic ones. There are many other bioplastics in existence that scientists are continuing to develop in the hope of solving the plastic problem. It is clear to see that biodegradable polymers are the future of scientific innovation.